seconds. Then again I am coming back. Why? Because after applying the load again I am getting reducing the weight. This one I am changing to 200 again for 30 seconds. Then 150 for 35 seconds. Then 100 for 40 seconds. Then 50 for 45 seconds. Then 0. Like that I am specifying the loads here. Okay. Now force assigned, support assigned. Now we have to check the result. Just click on solve. Now it has been solved here. Now we have to check what are the results required. I am checking here total deformation. I am checking here equivalent stress. Evaluate all results. Now see here total deformation. Okay, total deformation. When you specifying the load now, so initially for 1 second you got the deformation this much. For 1.5 seconds, this much. 2 seconds like that. So like that, why? Because we have specified the time interval difference as 0.5. 0.5 second difference we specified there, due to which for every 0.5 seconds, how the body is getting deformed here. For 1 second, I am getting this much deformation. When it reaches to around some 25 seconds, here we will get the maximum deformation. Then again it will reduce the deformation. Why? Because the weight is reducing there. Like that. So every 0.5 seconds you can able to see the results. I will change the weights here to find some more deformations. Go for force. These things I will keep like 500, 1000, 1500, 2000, 2500, 2000, 1500, 1000, 500. Okay. Now click on solve. Why? Because I am getting very negligible deformations there. It is like 10 to the power of -8. So it is like negligible only completely. So to see some values, I am getting the values here. Now see here. Now I assign the load here. Now I am checking the total deformation. I am getting still the values are very small here. For initial seconds we are getting from these values. When we reaches to here, it is increasing until 25 seconds. it will reach the maximum deformation. Yeah, the 25 is a maximum deformation that is of 3.1969 e to the power of minus 6. See here, till 25 I am increasing the load, like till 25 seconds I am increasing the load, like that the deformation is getting increased. After 25 seconds I am again start reducing the time. So our deformation also getting reduced here. Okay, like after like 3.1969 and 3.1322, 3.0676, 3.0045, 2 point like that, it will vary. So it's depend on your time. Like that we can able to check the results. Okay, sorry for that. Actually it is in meter, that's why reason it is coming like that. I am changing to mm. So we are getting some less value here. At maximum time, like the time where we are specifying the maximum, the time we are getting 3.1969 e to the power of minus 3. Where it's gone here? Why is it hiding? So like that we can able to find here, like for 25 seconds it's more, for around 40 seconds it is different, that is 0.069156. Pressure, like stress we are getting, like maximum stress. So like that we have to perform the analysis here. Understand guys this transient structure? If you have any doubt you can ask me, or if you want to tell like one more example after explain, I will explain. Take part. Is there any doubt? Are you there guys?
Yes, sir.
Is there any doubt? No doubts. Nothing is there guys. It's same like static structural only. The only difference you can find here is in static structural you are not specifying loads by considering the time. Directly you specify the loads there. But here when you come to the transient structural, we have to specify the load based on the time interval. So based on that time interval only, it will show the results. Like for every second, how the boundary conditions or how the behavior of the object changing. Okay. Do you want to explain me one more example, or shall I proceed for the next analysis? Like transient thermal. Anyone? Respond me, please. Shall I tell one more example, or shall I proceed for the next type of analysis?
So, tell another example.
Okay, fine. See here I have done like this, huh? Okay, one
Sir,
more.
I have one more.
Yeah, tell me.
Doubt. Is that frequency when you adjusting that I didn't quite get that part.
Sorry?
That you were I get that part when you were adjusting the time, that initial step time thing.
Yeah.
That can you just tell that once again?
Okay, fine. See here, now you can easily understand the thing. Initially it is somewhat difficult for you, but right now you can easily understand. Now come to here, analysis settings. So total time interval, how much you want? Like you are performing the analysis for how much time? That thing you have to specify step and time. Means you perform whatever analysis you are performing here. So it is for how much time? The first step you have to give there. The next step is here it is asking me three things. Initial time step means, suppose for example if you are performing for the 50 seconds. So from which second you want to calculate the results? From what time you want to start the analysis and from what time you want to start showing the result? I want to start showing the result from 1 second. For example, I am changing this one from 1 second to 20 seconds, for example. It is not taking 2 seconds. It is also not taking 1 second. Why it is not taking 2 seconds also? Why? Because time always starts from 1 second. It will not start for 2 seconds, 3 seconds like that. Okay? So it should be coming from the 1 second. So initial time should be 1 second. Then these two things we can match according to your requirement. But remember one thing, what is the maximum time step you are giving here? Now it should be equal, less than or equals to initial time step. These two values also. Both the values should be less than or equal to 1 second. Okay? For example, if I keep minimum time step as 2, it will take or not? No, it will not. Okay. Why? Because of this initial time step. So it should be less than or equals to 1. Minimum time step, I am giving 0.5 seconds here, for example, how I given initially. Now click on solve. Initial time step means, minimum time step means the gap between each interval, means how you want to see the result between each interval. So what is the time interval you have to specify? Okay, what is the time interval you want to give? For example, here, if you go to results checking here now, you can find that in each result you can find 0.5 second gap for each second. For each result, here 1, 1.5, 2, 2.5. So these are the time interval steps which we are giving here. So for every half second, it is showing the result. That is the thing you are specifying in the analysis, that is 0.5 seconds. Maximum time step is, usually it will take 0.5, like minimum time step only, but sometimes what happens, it will not take minimum time step because of some reason. So what it will do, it will go for the maximum time step. In rare cases, in very rare cases, it will go for 1 second, otherwise it will go for the maximum time step. Sorry, minimum time step. So that is the settings we have to go here before starting the analysis. Understand? Understand, guys?
Yes, sir.
Okay, then fine. Now we have to go for performing one more analysis here on this one only by taking some other problem like transient structure. Go for changing the engineering data. I'm taking here, for example, pattern, close, go for model. Yeah, it opened. Now, initially I've taken some different position. Right now we'll take some different. I will take here L angle, for example. Change the units to millimeter. Wait a second, guys. I will be back in 2 seconds. Sorry, guys. Now see here, I am taking here L section, and dimension I am specifying like width 1, width 2, thickness 1, thickness 2. Width I want here 100. One is 100 I want, the other one I am giving like some 150, for example. Generate. Sorry, thickness I want to change here. This one I am giving like 25. Generate, extrude, this cross section, apply. I want the thickness to be like 1000 mm. Generate. This is my L section here, right? Okay, L section I'm giving here. Now I will go for the mechanical environment to assign boundary conditions. I need to assign the settings. Yeah. Now see here, this is my L section. I am taking this in that manner, for example. First of all, go for geometry, change the material to cast iron. Different material are required. Let's see, we can able to change the material now. Let's see. I want here stainless steel. Okay, I will take stainless steel also. I will take factor here. Go for model. Yes, I want to update the steel. Now, first of all, I will perform the analysis for stainless steel. Okay. Now, the next thing is okay. Generate the mesh. The mesh has been generated here. Now, go for analysis setting. So maximum current time. What is the step like? What is the current? So its total time interval you want to give for the analysis here. I am giving, for example, some 300 seconds. Current step I am giving. See, previously we have given 1 as a step. I am giving currently the step to be like 2. And the initial time I am starting from 5 seconds. 1 second. Minimum time step I am giving like 5 seconds only, and maximum step I am giving like 5 seconds. Okay, you can increase this thing to 10 seconds. Yeah, like that. Like that, I am giving the time intervals here. After giving the time intervals, go for giving the boundary condition. The first thing is I am giving here fixed support, or we can go for any other support also. Cylindrical support will not give. Frictional support. Frictional support now. Here we will give fixed support only. So what I will do here, I am performing welding to the bottom face here. Where I have to specify welding. Yeah, here only I will specify the welding of the part. So it is a fixed support. Then what we have to do means, for the top side we have to specify the load, like pressure I am giving here. So insert, why? Because if I take force point at a particular point only it will assign. But when you go for pressure, for whole body it will assign. Okay? So whatever you want you can take. Like pressure is your force per area. It is only a force only. So I am going for pressure. On this place I want to assign, apply, and I want to give here loads under time intervals. Go for tabular data. 0 to 300 seconds we have given every 2 steps here, and we have given the maximum minimum times also there. So for 0 seconds I am giving 0 pressure, and I am giving, it is a megapascal here now, so we don't require that much big value. We will change this to bars also. Where is bars? Okay, Pascal down. Okay, pressure bars. Okay, for 300 seconds I am giving like 2 bars. Not for 300, I am giving for 50 seconds. For 50 seconds I am giving like 2 bars. For 100 seconds I am giving like 5 bars. For 150 for 100 I am giving like 5 bars. For 150 seconds I am giving like 8 bars. For 200 seconds giving 10 bars. Then 250 seconds, this one I am giving like 8 for 250 seconds. This one I am giving like 0. Like the different values I am specifying here. So we will give jogged values also here, like 8, 8, 10. Yeah. Here I will give this one like 0. Like we are jogging here, like we are changing the values according to our events, increasing, decreasing, increasing, decreasing, like the jog values I am giving here. Now pressure we have taken, click on solve. Now see here guys, it gets solved here. Now we have to check the results. Like I am checking total deformation, then I am checking here equivalent stress, and I am checking here right click, insert, tools, click insert, factor of safety. Okay. Now total deformation, see here how much we are able to see. Wait a second, why it's lifting there? See here, we are getting total deformation for initial 5 seconds is 3.578. For 10 seconds, 7.0717. 15 seconds, 20 seconds, 25 seconds, 30 seconds, 35 seconds, 40 seconds. See here, initially it is increasing. After 16 point, means after 25 seconds, it is again decreasing to 14.14, then 11.891, again 9.54, 7.0, 4.4, 3, 2, 1, like that. Again, after some value like 0, this value 0.0006283, then again it's getting increased here. Why? Because we have jogged our values, like we have given jogged values there. So that is the reason it is coming like that. So based on your load only, the deformations we can able to see there. So how much deformation is coming under this particular second after specify the loads like that, means we can able to find it. Okay, understand guys, like that only we can able to find here equivalent stress. Like initially for 5 seconds is 62.006 bars, changing to megapascal. That much big stresses we are getting here. 620. So right now that much pressure we cannot able to specify on the body. If I specify, means our body is getting damaged. Why? Because our what we can say, yield point is some 340 megapascal, but right now we are getting 680 megapascal. So the object is getting failed here. So like that we have to check the results. Okay, understand guys? If you are getting any doubt, you can ask.
Yes.
Then we will check here factor of safety. Factor of safety is showing like 15 here. Means what is factor of safety means? It is a ratio between actual stress by maximum, no? Maximum stress by yield point, something formula is there, na? Yield point, anyone knows? Even I also know, but I forgot actually. Something like that only. So under that ratio only, like whatever value you are specifying there, na? So it should be under that ratio only. So right now it is completely like equal ratio we are getting, so that is the reason the object is getting failed here. So we will change the pressure to some 10 megapascal, here 6 megapascal, here again 8 megapascal, 10 megapascal. Then click on solve. So we reduced our pressures here. Now we will check what are the results we are getting. Now first check the factor of safety here. Still it's showing like that. Means still we are getting the stresses more than the yield point. So that is the reason the object is getting damaged. So what I will do, I will change this one to If I change the material to cast iron, let's see what happens. Sorry. Now it gets solved here. Factor of safety, it is showing like 0 here. Total deformation, I'm getting around 3 point something. Equivalent stress is also getting very low. Why? Because compared to structural steel, cast iron value is less only. We'll put all those in. Why? Because it's a brittle material. Now I'm changing to structural steel, then we'll check the results. Here also we are getting like that. So here also it's getting damage only. Why? Because the here factor of safety, whatever the value is showing here now, it should be 3 times less. 3 times less should be there. Then only we can say our object is passing the stress analysis. Okay? Understand, guys? If you are getting any doubt, you can ask me. Otherwise, we will start the transient thermal.
I didn't get the last sentence you told about 3 times.
See here, the value is 15, it is showing here now. The maximum factor of safety. So it should be, if I like to pass the test, the value of factor of safety should be like around 5 point something like that. 5.8 like that. It should come. Then only the analysis we can say as a pass. Not exactly 5.5. If it is coming like 7.5, 8 like that, also we can say that it is passing the test. Otherwise, it is exceeding the 10 means we can say, we have to say that the object is failing here under that boundary conditions. Actually, what is factor of safety here? It is your like actual stress by theoretical stress, something like that. So it should be under one ratio. See, theoretical value anyhow is a theoretical value, so we can't able to change that value here. So that is standard. See, the theoretical value is the standard value. Okay, for that material, that much stress it can bear. After that one, it will deform completely. That is the actual property of that particular material. That one we can say as a theoretical stress. Then when we are applying the load, what the stress we are getting? Okay, if it's exceeding the limit, if it's exceeding the theoretical value, it is going anyhow like what is the theoretical? For example, the theoretical value is 350 megapascal for any material. Under that, if you are getting, after applying the load, if you are getting the stress value under the 350 megapascal, then it is safe. Why? Because after 350 the object is getting deformed, so we cannot consider that value. And if you are getting like, suppose for example, if your maximum stress is equivalent, like yield point is 350 megapascal, then if you are getting the value like 340 also, that is also failed. Why? Because it is very near to your yield point. Why? Because not only the load whatever you are specifying, that is considering here. Sometimes what happens, due to some other things also it will affect. So 10 we cannot consider like that. So that is the reason what they will do. Means usually they will consider like half or more than like 1.5, like not 1.5, 0.75 till 0.75, like 2/3. Up to 2/3 if you are getting the value, then it will consider. Otherwise it will not consider. Like for example, if you are getting the stress value 260, if the yield point is 350, then we can say that the analysis is passing. like the test is passing here. Otherwise, we can say that it is not passing here. The object is getting failed if it is crossing the 300 limit. So like that, some factor of safety values there. Okay, understand?
Yes, sir.
Now we'll start the transient thermal. See here, nothing difference you can find here. Only the assigning boundary condition is different here. Like here we are specifying the force, pressures, bearing load, point load, line pressure. Those things we are specifying here in static structure or transient structure. But when you go for thermal, either it may be transient thermal or normal thermal, there whatever values we are specifying, it is depend on time. That's it. Okay. I will create one small side drawing, and under that one we will perform the analysis. So go for transient thermal. Go for engineering data. I'm taking here copper alloy. Usually we will take copper only. If any thermal properties are affecting here, like for pipes, usually for pipes we are using copper only. So go for geometry. Create one cross section. Concept, cross section, circular tube. ID, OD we have to specify here. ID, inner radius is 10 mm, outer radius. I am giving inner radius like for example pipe size is 1 inch for 12 mm, 12 centimeters, so 120 mm. So I am giving here 120 mm. Sorry, outer is 120 mm. Inner I am giving like 0.133, it's around 100 mm. Okay. Yeah. 100. Go for extrude. Select the circular position. Okay. Extrude thickness I am giving like 1000. Generate. Very small here. Again I am giving to 10,000. Generate. Okay. That is my pipe.